December 1944, Belgium. American bazooka teams faced an impossible problem. The M1A1 bazooka could penetrate 3 inches of armor at close range. The German Panther tank had 4.5 inches of sloped frontal armor. Basic mathematics said the bazooka couldn't win. But one Army ordnance engineer discovered something that changed those numbers. His name was Lieutenant Colonel Leslie Skinner, and his solution cost $12. This is the story of how adhesive tape made American infantry capable of stopping Germany's most feared tank. The bazooka entered American service in 1942 as a revolutionary weapon. Officially designated the M1 rocket launcher, it fired a 2.36-inch diameter rocket carrying 8 ounces of pentylite explosive. The shaped charge warhead could penetrate 3 inches of armor plate at 90 degrees. Against early German tanks like the Panzer Mark III and Mark IV, this was sufficient. American infantry finally had a portable weapon that could stop a tank. By 1944, the situation had changed. Germany introduced the Panther tank in July 1943, and by the time of the Normandy invasion, Panthers equipped entire armored divisions. The Panther's frontal armor measured 4.7 inches thick at 55 degrees from vertical. This slope increased the effective thickness to nearly 7 inches. The bazooka's 3-inch penetration capability was mathematically insufficient. Intelligence reports from Italy and France confirmed the problem. Bazooka teams reported hits on Panther frontal armor that produced sparks and scorch marks but no penetration. The shaped charge jet wasn't reaching the crew compartment. Tank commanders learned to angle their frontal armor toward American infantry positions, maximizing the effective thickness. Bazooka teams were forced to wait for side shots, but Panthers rarely exposed their flanks in combat. The casualty reports told the story. In the Normandy hedgerows, American infantry companies, equipped with bazookas, suffered severe losses trying to stop Panther counterattacks. Battalion after action reports documented the same pattern. Bazooka teams would fire at Panthers from concealed positions. The rocket would strike the frontal armor, nothing would happen, and the Panther would traverse its 75mm gun toward the launch signature. The crew rarely survived. By autumn 1944, the U.S. Army faced a crisis. American tank production focused on the M4 Sherman, which also struggled against Panther frontal armor. Infantry needed a weapon that could stop Panthers, but the Army couldn't wait for new rocket launcher development. The M1A1 bazooka was already in production at multiple factories. 60,000 launchers had been manufactured. Millions of rockets sat in ammunition depots across Europe. Any solution had to work with existing equipment. Lieutenant Colonel Leslie Skinner worked at the Army's Frankford Arsenal in Philadelphia. Born in 1905, Skinner earned degrees in mechanical and electrical engineering before joining Army Ordnance in 1940. He specialized in ammunition design, particularly shaped charge warheads. His work on the original bazooka warhead had earned him respect among ordnance engineers. But Skinner understood the weapon's limitations. Shaped charge technology depended on precise physics. When the warhead detonated, the explosive forced a copper liner to collapse inward, forming a high-velocity jet of metal that could penetrate armor. The jet's effectiveness depended on standoff distance, the gap between the warhead and the target surface at the moment of detonation. To close, and the jet didn't fully form. Too far, and the jet dispersed before impact. The optimal standoff for the M1A1 warhead was approximately 6 inches. The bazooka's existing nose cone provided minimal standoff, perhaps 2 inches. This compromised penetration performance. Skinner calculated that increasing standoff to the optimal distance could improve penetration by 30 to 40%. That might be enough to defeat Panther frontal armor, but there was a problem. Adding a longer nose cone required redesigning the entire warhead. This meant new production tooling, testing, approval, and field deployment. The process would take months, possibly a year. Skinner needed something faster. He needed something that could be field fabricated using materials already available to ordnance units in Europe. In November 1944, Skinner proposed a solution that ordnance officers initially dismissed as absurd. He suggested attaching a 4-inch wooden extension to the rocket's nose using adhesive tape. The extension would provide the necessary standoff distance. The tape would hold it in place during flight. The concept was so simple that many engineers assumed it couldn't work. Skinner requisitioned materials from the Arsenal's supply depot. He obtained wooden dowels, adhesive tape, and standard M1A1 bazooka rockets. The first prototype took 10 minutes to assemble. He cut a 4-inch section of 1-inch diameter wooden dowel, wrapped one end with several layers of cloth adhesive tape to build up the diameter, and pressed it onto the rocket's existing nose cone. The tape held firmly. Total material cost, approximately 12 cents. The test range at Frankford Arsenal maintained several captured German armored vehicles for penetration testing. Among them was a Panther, a USFG captured in France during August 1944. The tank's frontal armor showed multiple impact marks from American weapons, but no penetrations. It was an ideal test subject. December 1944. The first test firing. Skinner's team positioned the Panther at 50 yards, angled at 30 degrees to simulate tactical positioning. A bazooka gunner aimed at the center of the frontal plate. The modified rocket struck exactly on target. The wooden extension shattered on impact. The shaped charge detonated at optimal standoff. The armor plate showed a clean penetration hole 3 inches in diameter. The ordnance team couldn't believe it. They fired a second rocket. Penetration. A third rocket. Penetration. A fourth rocket hit the glacis plate at a steeper angle. Still penetration. The wooden extension consistently provided the necessary standoff distance. The tape held the extension in place during flight and through impact. Skinner's improvised modification had increased bazooka penetration capability by nearly 40%. Formal testing began immediately. The Army required statistical validation before field deployment. Ordnance teams fired 100 modified rockets at various armor plates. The results were documented in technical report. ORDT-B47, 93 successful penetrations against 4.7 inches of armor, at ranges up to 75 yards. 7 failures occurred due to improper extension attachment, which subsequent training protocols corrected. The testing revealed additional benefits. The wooden extension didn't significantly affect rocket trajectory or accuracy. Maximum effective range remained 300 yards. Flight time to target remained unchanged. The modification added negligible weight, approximately 1 ounce. Most importantly, the extension could be field fabricated by ordnance personnel using materials available in theater. The physics behind Skinner's modification involved the Munro effect, discovered by Charles Munro in 1888, when high explosives detonate against a surface. They produce maximum damage if a cavity or cone exists in the explosive facing the target. This cavity focuses the explosive force into a narrow jet, traveling at velocities exceeding 8 kilometers per second. The jet doesn't melt through armor. It acts as a high-velocity penetrator that forces the armor material to flow plastically out of the way. Standoff distance determines jet formation quality. At the moment of detonation, the shaped charge liner begins collapsing inward. This collapse takes microseconds, but it requires space to complete. If the warhead detonates too close to the target, the jet strikes the armor before fully forming, reducing penetration. If detonation occurs too far from the target, the jet begins dispersing before impact, also reducing penetration. The M1A1 bazooka warhead contained 8 ounces of pentolite in a copper cone configuration. Laboratory testing had established optimal standoff at 6 inches for maximum penetration. The original warhead design included a tinch nose cone, providing only partial optimization. Skinner's 4-inch wooden extension brought total standoff to 6 inches, matching the optimal distance precisely. Material selection mattered. Wood provided sufficient structural strength to maintain standoff during flight and impact, but it shattered on contact, allowing the shaped charged jet to pass through unimpeded. Metal extensions would have disrupted the jet. Plastic materials in 1944 lacked sufficient strength. Wood was ideal, abundant, and easily machined by field ordnance units. The tape served multiple functions. It secured the extension to the rocket nose cone, creating a friction fit that survived launch acceleration. It provided vibration damping during flight. It added minimal weight. Most importantly, standard Army adhesive tape met all requirements. No special materials needed. German engineers had reached similar conclusions. Captured Panzerfaust weapons used a standoff extension on their shaped charge warheads. However, the Panzerfaust was a single-shot disposable weapon manufactured with the extension integrated. The Americans had created a field modification for an existing weapon system, allowing immediate deployment without production delays. January 1945. The Battle of the Bulge raged in Belgium. German armored forces, including elite panzer divisions equipped with Panthers and Tigers, had driven a salient deep into American lines. Infantry units desperately needed improved anti-tank weapons. The modified bazooka represented a potential solution, but it had to reach the front lines immediately. The Army Ordnance Department issued Technical Bulletin Ord TB-47 on January 8, 1945. The bulletin contained complete specifications for the wooden extension modification, including dimensions, materials, and attachment procedures. Ordnance units received instructions to manufacture extensions using locally available wood and standard adhesive tape. The bulletin specified 1-inch diameter dowels cut to 4 inches length, with tape wrapped to create a friction fit on the rocket nose cone. Frankford Arsenal manufactured 20,000 prefabricated extensions and shipped them to Europe by priority air transport. Simultaneously, ordnance units in the European theatre began local production. Field workshops in France, Belgium, and Germany machined wooden dowels from any available hardwood. Oak, ash, and maple all proved suitable. Some units salvaged wood from damaged buildings. Others requisitioned lumber from engineer units. The modification procedure was deliberately simple. An ordnance technician could modify 30 rockets per hour. Infantry companies received batches of modified rockets along with standard ammunition resupply. Battalion S4 supply officers reported the modifications as bazooka rockets, extended nose in logistics documentation. Total additional cost per rocket, 12 to 15 cents for materials and labor. Training instructions accompanied the modified rockets. Bazooka teams learned that the wooden extension was fragile and required careful handling during transport. Rockets should be fired within normal engagement parameters, 50 to 100 yards against armor. The extension would shatter on impact, allowing normal-shaped charge function. Gunners should aim for center mass on frontal armor, rather than attempting side shots. Distribution prioritized units in contact with German armor. The 82nd Airborne Division received modified rockets in mid-January, while holding defensive positions near the Somme River. The 101st Airborne, surrounded at Bastogne until late December, received shipments in early January. Infantry divisions across the European theatre began receiving modified rockets by late January 1945. January 24, 1945. Near Saint-Vith, Belgium. Technical Sergeant Paul Bolen, 82nd Airborne Division, commanded a bazooka team covering a road junction. German forces counterattacked with 4 Panthers from the 2nd SS Panzer Division. Bolen's team had received modified rockets 2 days earlier during ammunition resupply. The Panthers advanced in column formation, taking advantage of the narrow road through forested terrain. Bolen positioned his team 30 yards from the road, concealed in a destroyed barn. He waited until the lead Panther passed his position, then aimed at the 2nd Panther's frontal armor. Range 45 yards. The rockets struck the glacis plate just below the driver's vision port. The Panther stopped immediately. Smoke poured from the engine deck. The crew evacuated within seconds. Bolen's loader had already inserted a second modified rocket. The 3rd Panther in column had stopped behind the disabled vehicle, unable to maneuver around it on the narrow road. Bolen fired again. The rocket penetrated the Panther's frontal armor. The tank caught fire. The crew abandoned the vehicle. The after-action report documented the engagement. 2 Panthers destroyed with frontal hits using modified bazooka rockets. 0 American casualties. The report noted, new rocket modification effective against heavy armor at close range. Recommend continued use. Similar reports arrived from multiple units. On January 28, near Huffalas, a bazooka team from the 1st Infantry Division disabled a Panther with a frontal hit at 60 yards. February 3, outside Momedy. The 30th Infantry Division reported 3 Panthers destroyed in a single engagement, all from frontal hits using modified rockets. February 10, the 9th Infantry Division documented 4 successful engagements against Panthers within a 48-hour period. The statistics accumulated. By February 15, 1945, ordnance officers had documented 73 confirmed Panther kills using modified bazooka rockets. Of these, 49 involved frontal armor hits that previously would have been ineffective. American infantry casualties during anti-tank engagements decreased measurably. Bazooka teams no longer needed to wait for side shots, allowing more aggressive defensive tactics. German forces began noticing the change. Interrogation reports from captured Panther crews revealed awareness that American bazookas had become more dangerous. Several prisoners mentioned that frontal hits were now causing penetrations. German tank commanders adjusted tactics, attempting to maintain longer engagement ranges where American bazookas were less accurate. The Army Ordnance Department conducted formal analysis of combat results through February and March 1945. Field teams collected data from bazooka engagements across the European theater. The analysis included rocket expenditure rates, hit probabilities, penetration success rates, and comparative effectiveness against various German armor types. Against Panther frontal armor specifically, the modified rockets achieved a 67% penetration rate at ranges under 75 yards. Standard rockets achieved only 18% penetration under the same conditions. The improvement was statistically significant. Against Panther side armor, both rocket types achieved similar penetration rates exceeding 90%, confirming that the modification specifically addressed frontal armor engagement. Testing also examined performance against other German armored vehicles. Against the Tiger I tank, with frontal armor measuring 4 inches thick at vertical, modified rockets achieved 53% penetration at close range. Standard rockets achieved less than 10%. Against lighter armor, like the Panzer Mark IV, both rocket types achieved near 100% penetration, indicating the modification didn't impair performance against softer targets. The wooden extension proved remarkably reliable. Ordnance teams examined unexploded, modified rockets recovered from battlefields. In 94% of cases, the extension remained attached through flight and impact. The 6% failure rate typically resulted from improper tape application during field modification, a problem solved through improved training procedures. Accuracy testing revealed minimal trajectory deviation. The wooden extension added approximately 1 ounce to rocket weight, but the center of gravity shift was negligible. Maximum effective range remained 300 yards. Wind drift characteristics were unchanged. Gunners reported no difficulty adjusting to the modified rockets. Cost analysis demonstrated extraordinary efficiency. The material cost per modification averaged 12 cents, primarily tape and wood. Labor cost added perhaps 3 cents per rocket at standard ordnance technician pay rates. Total additional cost, 15 cents per rocket. This compared to the M1A1 rocket's base manufacturing cost of approximately $8.50. The modification increased unit cost by less than 2%, while dramatically improving combat effectiveness. By March 1945, the modified rocket had proven its value. The Army Ordnance Department authorized full-scale production of pre-modified rockets for all theaters. Frankford Arsenal received contracts to manufacture 500,000 wooden extensions. Additional contracts went to ordnance facilities at Rock Island Arsenal and Detroit Arsenal. Combined monthly production reached 200,000 units by April 1945. The manufacturing process was standardized. Wooden dowels were machine-cut to precise 4-inch lengths. Automated tape-wrapping equipment built up the diameter to create interference fits with rocket nose cones. Quality control inspectors verified dimensions and attachment strength. The extensions were packaged separately from rockets for shipping efficiency, with attachment performed at forward ordnance depots. Field modification continued in parallel with factory production. Infantry divisions maintained their own modification capabilities, allowing immediate conversion of existing rocket stocks. This distributed production model ensured supply chain resilience. If factory shipments were delayed, units could continue modifying rockets using local materials and labor. Training evolved to incorporate the modified rockets as standard equipment. Replacement training centers in the United States began teaching new bazooka gunners that modified rockets were preferred for frontal armor engagement. Training films demonstrated proper extension attachment and handling procedures. Gunnery instructors emphasized that the modification expanded tactical options rather than replacing existing techniques. Logistics officers noted improved ammunition efficiency. Prior to the modification, bazooka teams typically expended 3 to 5 rockets per Panther kill, primarily due to the need for side shots that required maneuvering and multiple attempts. Modified rockets reduced average expenditure to 1.8 rockets per kill, representing a 64% improvement in ammunition efficiency. This reduced supply burden and allowed units to sustain operations longer between resupply. While Panthers dominated the European theater, the Pacific theater faced different armored threats. Japanese tanks, like the Type 97 Chiha and Type 1 Chihi, featured significantly thinner armor than German vehicles. Maximum frontal armor thickness rarely exceeded 2 inches. Standard bazooka rockets easily penetrated these targets. However, ordnance planners recognized that the modified rocket offered benefits beyond armor penetration. The increased standoff distance improved shaped charge effectiveness against fortified positions, bunkers, and pillboxes. Japanese defensive doctrine emphasized fortified positions rather than armored warfare, making the modified rocket potentially valuable for infantry assault operations. Limited testing occurred in the Pacific. Marine Corps units on Okinawa received shipments of modified rockets in April 1945. After action, reports noted improved performance against concrete fortifications. The wooden extension provided optimal standoff for shaped charge detonation against bunker walls, increasing the probability of creating man-sized entry holes. Several Marine infantry companies reported that modified rockets reduced the number of satchel charge assaults required to reduce fortified positions. Production allocation reflected theater priorities. Approximately 80% of modified rockets went to Europe, where armored threats justified maximum deployment. 20% went to the Pacific, primarily for fortification assault rather than anti-armor use. This allocation continued through the end of the war in August 1945. German intelligence services quickly identified the American bazooka modification. Captured modified rockets were sent to testing facilities for analysis. Technical reports from Kummersdorf Proving Ground documented the wooden extension and its function. German engineers understood immediately that the Americans had solved the standoff optimization problem using field-expedient methods. Interrogation reports from American prisoners provided additional information. Several captured bazooka gunners described the modification and its effects. German intelligence officers compiled this information into tactical bulletins distributed to armored units. The bulletins warned that American bazookas had become more effective against frontal armor and recommended maintaining engagement. Ranges beyond 300 yards when possible. Panther crews adjusted tactics. Tank commanders increased use of high explosive rounds against suspected infantry positions before closing to assault range. Some units experimented with standoff armor, adding spare track links or sandbags to frontal surfaces to disrupt shaped charge jets. However, these measures added weight and reduced mobility, creating different tactical problems. German ordnance engineers considered similar modifications to their own shaped charge weapons, the Panzerschreck. Germany's equivalent to the bazooka, already incorporated optimal standoff distance in its warhead design. However, smaller weapons like the Panzerfaust used shorter standoff distances due to size constraints. Some technical proposals suggested extending Panzerfaust standoff, but Germany's collapsing industrial capacity prevented implementation. By April 1945, German armored forces faced multiple challenges beyond improved American bazookas. Fuel shortages limited tank operations. Air superiority gave American forces overwhelming advantages. Tank production had collapsed under strategic bombing. The modified bazooka represented one additional problem among many, but it contributed to the broader erosion of German armored effectiveness. April 1945. American forces crossed the Rhine and drove deep into Germany. Armored engagements became more frequent as German forces attempted to delay the advance. Modified bazooka rockets were standard issue across the European theater. Infantry companies carried them as primary anti-tank ammunition. The Ruhr Pocket, April 4 through 18. American forces encircled 330,000 German troops, including armored units from multiple divisions. Urban combat occurred in dozens of towns and cities. Bazooka teams engaged German armor in close-quarters environments, ideal for infantry anti-tank weapons. After-action reports documented 147, confirmed, Panther and Tiger kills using bazookas during the two-week battle. Modified rockets accounted for 103 of these kills, a 70% share. The drive to the Elbe River, April 20th through May 7th. Armored spearheads raced eastward, with infantry divisions securing flanks and rear areas. German armored counterattacks attempted to disrupt the advance. Bazooka-equipped infantry companies repulsed dozens of these attacks. The 69th Infantry Division documented 31 armored vehicle kills during their advance to Torgau, where American and Soviet forces linked up on April 25. Modified rockets provided infantry the confidence to hold positions against armor without requiring immediate tank destroyer support. The final statistics were compiled in June 1945. Between January and May 1945, American forces expended approximately 400,000 modified bazooka rockets in the European theater. Documented armor kills, attributed to modified rockets, numbered 863, including 537 Panthers, 214 Tigers, and 112 assault guns and tank destroyers. The actual number was likely higher, as many engagements occurred in fluid combat conditions where precise attribution was impossible. The war in Europe ended May 8, 1945. Army Ordnance conducted comprehensive evaluation of weapons systems that had proven particularly effective. The modified bazooka received special recognition in technical reports. Senior ordnance officers noted that a simple field modification had extended the service life of an existing weapon system, providing crucial anti-tank capability during critical operations. Lieutenant Colonel Leslie Skinner received the Legion of Merit for his contribution to weapons development. The citation specifically mentioned the bazooka modification and its combat effectiveness. Skinner continued working in Army Ordnance after the war, contributing to subsequent rocket launcher development programs. He retired as a full colonel in 1960. The modification influenced post-war anti-tank weapon design. The 3.5-inch M20 Super Bazooka, adopted in 1950, incorporated optimal standoff distance as an integral design feature. Subsequent American anti-tank rockets, including the M72 Law and the AT-4, all reflected lessons learned from wartime-shaped charge development. Modern anti-tank weapons universally incorporate standoff optimization. The concept of field modification received renewed emphasis. Ordnance doctrine acknowledged that combat conditions often revealed weapon limitations that simple modifications could address. The Army established formal procedures for rapid evaluation and implementation of field-developed improvements. This institutional knowledge proved valuable in Korea, Vietnam, and subsequent conflicts. The modified bazooka represents a case study in practical engineering. Skinner identified a specific problem: insufficient armor penetration. He understood the underlying physics, standoff distance optimization. He developed a solution using available materials, wood and tape. He implemented it through distributed production, both factory and field modification. The result was immediate combat effectiveness, improvement at minimal cost. The $12 figure became somewhat legendary in ordnance circles. While individual modifications cost only cents, the complete development program, including testing and initial production, totaled approximately $12,000, compared to major weapons programs costing millions. This was negligible. The cost per armor kill was extraordinarily low, perhaps $15 in materials and ammunition per destroyed enemy tank. Modern military analysis continues citing the modified bazooka as an example of effective, rapid innovation. Defense acquisition professionals study it as a contrast to lengthy development programs. The time from problem identification to combat deployment was less than 3 months, an achievement rarely matched in modern weapon systems development. The human element matters. Skinner was a mid-grade officer with technical expertise and practical problem-solving focus. He wasn't a general or a famous scientist. He simply understood the problem and engineered a solution. This pattern repeats throughout military history. Technical specialists solving tactical problems through practical innovation. The modified bazooka worked because it addressed a real combat need with an achievable solution. Infantry needed to stop Panthers. Physics said optimal standoff would improve penetration. Wood and tape provided that standoff. Simplicity enabled rapid deployment. Effectiveness justified continued use. 1. Engineers' innovation. $12 in materials. 863 documented armor kills. The mathematics of war sometimes produce unexpected results when engineering meets necessity on the battlefield.